Hello, this is the review for the quiz on Activity 32, Vectors. There are 19 questions on the quiz total. Really a little bit of everything. So some of these questions are on here more than once, and on the quiz they're really on there only once. So for the very first problem, two vectors are equal. This is definitely on there. There's one question like this. They have the same magnitude and direction. So they have to be at the exact same angle and they have to have the same length. For number 2, we're going to put this into component form and then determine the magnitude. The magnitude is its length, and it says no decimals clearly, so we're going to have a radical or a whole number. This is head minus tail. There is one question like the two of these. So the idea is one question where you'll have to put it in component form and then answer some questions based on that component form. So head minus tail, so we would do -3 minus 4. And then for the other part of the vector, the other component, 1 minus 8. So the component form of this is -7, -7. So now to find the magnitude of vector v, would be the square root of 7 squared plus 7 squared, or 7 radical 2. For number 3, in standard position, that means the tail is at 0, 0. So the component form of this vector is 9, -6. And then, of course, the magnitude of vector u would be 9 squared plus 6 squared. And then add that up and reduce that. This is 3 radical 13. I'm just skipping the arithmetic to save time. You don't need to watch me add and break that down. Now, number 4 and 5, I put this on here twice because it seemed like this was a problem when we did this not too long ago. So I put it on there twice. There is one question like all these. So there's one question like the component form, and there is one question about interpreting something about the question. So it's up to you whether you want to think of that as 4A and B or 5A and B. I mean, they're virtually the same question. So for the first question here, we've got the beginning and the end coordinates. Beginning and end coordinates. So you again would do 17, oops, sorry, I'm looking at the wrong number. 20 minus 12 for the component form, 20 minus 12, and then we would have 17 minus 8. Remember, the signs are important, so if you do it backwards, you do get the wrong signs. So the component form is 8, 9. And the component form means that this was, since the y-axis is the positive and it's pointing north, so the positive y-axis is up and that's north. So this means we would be 8 kilometers east and 9 kilometers north of the starting spot. So you explain each component as a horizontal or vertical direction. Now, magnitude of this exact same vector, magnitude is the length, and so the magnitude is the hypotenuse. So we would have 8 squared plus 9 squared. And you can have a decimal for this. First of all, it doesn't say you can't, and because it's a story problem, you would not really express your distance with a square root, I'm assuming. So this doesn't say what to round to, so do the decimal. I'm going to call it 12.04 kilometers. So number 5 is basically the same question. It's just set up a little bit different. So we've got the first hour, and this is how it moved. He moved, so 3 units to the right and 1 unit down. It doesn't really give us a direction of north, south, east, or west. And so then the second hour, he moved 2 to the left, and 2 down. So his total change in position would be to just add those two together. And so again, if you add x plus x, we would get 1. If you add y plus y, we would get -3. And then what vector? So that's the vector. And explain this. So this is the sum of each hour. Almost wrote the wrong hour. Oh, hi. That's not an eraser, in case you wondered. And it's not erasing. So if we added up each separate hour, this would be the total of his movements. I think that just makes sense. And then for part B, they want to know if he turned around and walked back. So imagine he went here. So imagine you put all these vectors together, and they just want to know if he were to go in a straight line position back to where he started. What would you do? Or how long would it be? This is, of course, just distance. It's magnitude, 1 squared and 3 squared. And so this would be radical 10, which, of course, you would say 3.2. This is miles. Graphing. There are 2 questions like these. There's actually, on the quiz I have it set up a little bit different. After you go through and add them symbolically and geometrically, then I ask you to calculate the magnitude, I think, and the direction. So it's really 4 parts to these questions, but there are 2 of them. So there's just one way to tie in magnitude and direction without having separate problems. So in order to do this symbolically, that is the arithmetic. So we would have 2 times vector t, so 2 times 2, 1, plus vector s, 1, -4. Doesn't matter which one you do first. We have 4, 2, plus 1, -4. And so the result of that addition would be 5, -2. Now, of course, the goal is that we would be able to draw this and show that same answer on the graph. So you start at 0, 0, and I'm going to do 2t first, since t is the first one listed, and t is 2 to the right and up 1. So there's 1t, and then I can do it again, 2 to the right and up 1. So you can do that as 1 vector or 2 vectors. There's 2t. Now you start where that one ends, and you count for vector s. Vector s was 1 to the right and 4 down. So we're here. So there's a vector s. So I did red, then blue. And then your answer, of course, is connecting that to 0, 0. Now it does look like it's at 5, -2. So you should have 2 arrows pointing at what you consider to be the answer. Now when you have a negative vector, that's just saying to take the opposite of it. So we're going to have the opposite of s, which is going to be -1, 4. And we're going to add 2t. Now we just did 2t, so one can easily look back at that. That's 4, 2. So when you add these together, we would get 3, 6. So again, that's the goal, to try to get something that points at the point 36. Oops. I'm going to try to change this color a little bit. So we've got the opposite of s, which means we have to go the way I have it written here. So that means from 0, 0, 1 to the left, up 4. So there is -s. Should have an arrow there. This is hard. I know it's hard to see. I'll try to make it bigger. So that's -s. Now from there, we're going to count 2t, which of course I've indicated that right here. So that's to the right 4 and then up 2. And so there's the arrow here. So the arrowhead is again landing there. And then your resultant, your answer, would be from 0, 0. And it does look like it's right at 3, 6, like we thought it would be. Now when you subtract, subtracting is really adding the opposite or doing the additive inverse. So for 2r, we have 2 times -3, 2. So that would be -6, 4. And to that, we are going to add the opposite of s. So we're going to add -1, 4. That's how we're going to graph it as well. So the answer for the symbolic or the algebra would be -7, 8. So it kind of gives you an idea as to where you should end up. Obviously, we're over there in the second quadrant. So again, I'll start by graphing 2r, so that would be -6 up 4. And you connect that to 0, 0. That's where your arrow goes. Now we would going to do the add of the opposite. This is how you subtract. So we're going to go -1. Sorry, I'm just looking at my picture. It looks weird. So -1 means we'd go 1 to the right, and then we'd go up 4. So 1 to the right. That's not -1. We would go 1 to the left, sorry, and up 4. 1, 2, 3, 4. So 1, 1, 2, 3, 4. So we're up here. So we're back 7, and I think we're up 8. Yep, we are. So you're right here on the edge, and the resultant connects to 0, 0, and the arrow points at the answer. All right, so then you can see the next thing is magnitude and direction. Magnitude is the length, and the direction is the angle in which it points. Sorry, this is like on the slant. It's like a weird perspective here. They're already in component form, so that's exactly what we're looking for. So first we're going to just do 2u. So 2u would be 14, -16. So when you go to do the magnitude of this, now notice that the directions say you can round to 2 decimal places, so you can throw this right into the calculator. So the magnitude of 2u is the square root of 14 squared plus 16 squared. And so that gives you 21.26. I would graph this 14 over and down 16. You're in the 4th quadrant, so you want to make sure you have a 4th quadrant angle. And so we would have the inverse tangent of b over a, -16 over 14, or you can do positive, it's up to you. Then, of course, you have to move that angle into the 4th quadrant by subtracting 360, and the angle is actually, we're going to 2 decimal places, 311.19. So w minus u, you want to do it in that order, please. Make sure you do that. So we would have, we can change this. I'm going to do this different. So we're going to have -10, 12. And instead of subtracting, I'm going to add the opposite. So I'm going to change u to -7, 8. So we would have, our component form would be -17, 20. And so then the length of this vector is the square root of 17 squared and 20 squared. Again, no negatives, and that's 26.25. And if you graph this, we would be -17 up 20, so we're here in the 2nd quadrant, so make sure you have an angle that's less than 180 and bigger than 90. So we're going to do the inverse tangent of 20 over -17. Putting that into the 2nd quadrant, we get 130.36 degrees. There's the angle, there's the length. So if you notice here, the first time we did this, the directions were different. The directions said if your angle's on the unit circle, then you can't have decimals. But the directions here said we can use decimals for all of them, and we can round to 2 decimal places. So that makes this extremely easy. Make sure your calculator is, of course, in degrees, but it should have been for 9 and 10 anyway. And so if you recall how we do this, we take the magnitude times the cosine of the angle. That's how you get x. And then we take the magnitude times the sine of the angle, and that's how you would get y. Now we are resolving this into component form, so you want to write that in component form, please. So 5.66 and 5.66, because they're both positive in the 1st quadrant. 11 times the cosine of -20, and 11 times the sine of -20. So this one is 10.34, and then the 2nd component is -3.76. There's one question like this one, and there are 2 questions like 9, and 10. Sorry, I forgot that part. Now 13, this whole thing, it kind of all goes together. This is, all of these parts are on the quiz. So you'll have to draw it, you'll have to determine the argument, and you'll have to calculate the absolute value. So we are dealing with -5 minus 12i. Now with this, please recall that this is the real axis and this is your imaginary axis. So you're going to run left and right first and then up and down. And to make it fit, I counted by 2's on the I-axis and 1's on the real axis, just so that would fit on the picture. I don't think we have enough to go down 12, so we're going to count by 2's. There it is labeled in the positive direction, so same as in the negative. So there's your vector. So you'll have to draw a vector that is a complex number. The argument is going to be the inverse tangent of b, not the I, just the b part over the a. And so then this would be in the third quadrant, of course, 247.38 degrees. And then to calculate the length, you do the square root of 5 squared and 12 squared. You drop the negatives, you drop the I, and this works out to be 13 exactly. In terms of simplifying complex numbers, there are 4 of these. Now this is set up a little bit different, where you don't have the numbers. You're going to have to constantly refer back to the directions. So just be aware of that. And again, make sure if you're using a calculator that you do put everything into parentheses. So for z plus w, we would have 4 minus 3i plus -2 minus 4i. And so we would get 4 minus 7i. Again, it has to be a plus bi. So for z, this is 4 minus 3i minus -2 minus 4i. So we'll change all the signs in the second one. So plus 2 plus 4i and combine like terms. So here we would get 6 plus 1i. Now this straight line above your number, this if you recall, means conjugate. This is the symbol for the conjugate. So the conjugate is to change the middle sign only. So the conjugate of z is 4 plus 3i. Of course, here we're multiplying. 4 minus 3i times -2 minus 4i. Calculator will probably give you this the fastest. It is distributive property, FOIL, all that good stuff. So -20 minus 10i. And of course, for division, the calculator still is going to be the best bet here. There are no radicals, so we can use the calculator, but I'm going to set this up first. 4 minus 3i, put that in parentheses, divided by w, which is -2 minus 4i. That must also go in parentheses. Please write your answer as a fraction with a common denominator. So it has a denominator of 10, and this is 2 plus 11i. Remember, the I must be in the numerator. I believe your calculator will give you 1/5 plus 11i over 10. I would take that answer as well, but 1/5 is the same thing as 2/10. So that's where I got that 2 from. There'll be one question like number 19. This is the one we just went over very recently. In order to find the distance between two complex numbers, you have to subtract first. So this is a subtraction problem, exactly like number 15. We're just going to go in order since it doesn't really tell us any different. So -2 plus 5i minus 7 minus 4i. So -2 plus 5i minus 7 plus 4i. So when we subtract this, we get -9 plus 9i. Now we'll use the distance formula. So to find the distance between these two, it will be, I don't have a name for it, but this is the symbol, right? It's the absolute value. It is the square root of a squared plus b squared, but they're both 9s. So 81 plus 81, take the square root of that. It does not say we can have a decimal, so don't have a decimal unless it gives you permission to have one. Or you can have a decimal if it's a story problem. Finally, we get to polar form. If you recall, polar form is r times cosine theta plus I sine theta. The r is on the outside of the parentheses. So you have to find that r first before you can actually write the form. So the r is, if you recall, the square root of a squared plus b squared. So 144 plus 9 is radical 153. The directions say nothing about decimals. So you can have a decimal for your angle, because that's really the only thing you can have, but this will be radical 153. And then for your angle, we of course have the inverse tangent of 3 over 12. No I, and it's negative 12. Make sure that this gets put in the correct quadrant. We are negative 12 up 3, so we're here in the second quadrant, and so the angle is 165.96. So then your answer for number 20 is the square root of 153 times the cosine of 165.96 plus I sine of 165.96. That's all number 20. So for 21, I have to come over here a little bit. Same process. There is only one question like this on the quiz. Of course, I just put some extra ones on here for practice. First thing, of course, we need is the r. And so that's the square root of 64 plus 25. Still can't have any decimals, so that's going to stay radical 89. It doesn't break down. For your angle, we have the inverse tangent of negative 5 over 8 second over first. And negative, or rather this is down here in the fourth quadrant. So make sure you have a big number here. So this angle is 327.99. I think. Yep, 327.99. So when we go to write this one, the numbers are so long. We're going to have radical 89, and then in parentheses, cosine of 327.99 plus I sine of 327.99. To put this in rectangular, it says no decimals. Again, so here you can see how the directions will be on the quiz as well. They keep switching back and forth. This is just distributive property. So we have 4 times the cosine of 315 plus 4i times the sine of 315. 315 is in your fourth quadrant, and so the cosine is positive. So this is 4 over 1 times radical 2 over 2. This is 4i over 1 times negative radical 2 over 2. So this is a number. It's not a vector. It's just a number, a plus bi. So we'll get 2 radical 2 minus 2i radical 2. A plus bi just means that there is a sign. It could be plus or minus in between the two pieces. So again, 14 cosine of 30 plus 14i sine of 30. We're in the first quadrant, so they're both positive. Cosine is radical 3 over 2. It's multiplying. Plus 14i, and of course the sine of 30 is 1/2. So here we would get, that reduces, 7 radical 3 plus 7i. Now we're going to multiply polars together. Remember, the trick is to multiply the radius numbers. So 8 times 9, that's your new radius. And then when you do the angles, you add them. So we would get the cosine of 255 plus I sine of 255. Oh, there's one question like this on the quiz. One question like this on the quiz. So for 25, again, multiply the numbers out in front. It is a multiplication problem, so you would expect you're going to have to multiply something, and then you add the angles. So it's kind of like adding powers. They're not powers. They're just angles. So we have the cosine of 145 plus I sine of that same number. So that is the whole quiz. Lots of distance formula and inverse tangent. So you'll need a calculator, of course. Later.